Hello, everybody. Good morning, good afternoon, or good evening. My name is Jean-Daniel Rossel. I'm the president of the Java Card Forum, and it's my pleasure to welcome you to this third webinar in our series of webinars. While we wait for the last people to connect, just a word about the Java Card Forum, which is an industry standard which drives the evolution of the Java Card technology. And Java Card is a successful, secure platform with billions of deployment over the last 20 years. And a couple of years ago, the Java Card 3.1 specification was issued by Oracle and had great, exciting new features, specially designed for the IoT market. The presentation we have today will focus on the benefits of Java Card on the IoT ecosystem, with a special focus on end-to-end security with IoT Safe Atlet for the TLS, and also the brand new integrated system on chip form factor. For that, we have 4 presenters from 2 companies. 2 presenters from Kigen, which is an ARM company, and for that we will have Paul Bradley, which is the Director of Strategy and Innovation at Kigen, and Anurag Sharma, which is IoT Safe R&D Lead at Kigen. Together with them, we'll have 2 persons from Orange, Leila De Charette, which is IoT Standardization Engineer at Orange, and Fabrice Fontaine, who is Embedded Systems Security Expert at Orange. If you have questions during the presentation, please leave them in the chat box. At the end of the presentation, we will open the microphone. You will be able to ask the question directly, or we'll go through the question on the chat. The presentation will be available to you tomorrow by mail and will be posted on the website of the webinars, so you can really focus on and listen to the speakers today. Paul, the floor is yours.
Thank you, Jean-Daniel. So good morning, good afternoon, and good evening from my side as well, and a warm welcome to you wherever you're listening to this webinar from. And I hope that you're keeping safe and well during these strange times. So my name is Paul Bradley, and as Jean-Daniel just mentioned, I direct strategy and innovation at Kigen, an ARM company. So firstly, a very big thank you to the Java Card Forum for inviting us to present today, and also to Jean-Daniel for the warm introductions. In today's webinar, we hope to show you how Java Card as a platform can be used to embed secure connectivity in devices where you never imagined possible. At Kigen, we're laser focused on reducing the power, size, and cost footprints of security to make cellular IoT scale. And to do that, we've been focused on 2 main technologies, integrated SIM or iSIM and IoT Safe. And today we'll take a look into each of them. We're running this webinar together with our partners from Orange, with whom we've been working on IoT Safe for some time already in preparing technology demonstrators. I'll take you through the iSIM technology and some first applications which we've put together with partners, and then run through an overview of IoT Safe together with Leila and Anurag. Leila and Anurag, would you like to introduce yourselves?
Yep. Thank you. Thank you very much, Paul. So Leila De Charette, I'm working as a standardization engineer at Orange. I'm representing Orange company and different standardization bodies and working on a security.
Anurag?
Hi, everyone. Yeah, thanks, Paul. Hi, everyone. This is Anurag Sharma, and I'm working as a senior software developer at Kigen, and I'm also responsible for IoT Safe development.
Great. And then last but not least, we'll take you through the IoT Safe technology and the demonstrator that we've built together. And to tell you more about that, we have Fabrice. Fabrice, would you like to introduce yourself?
Hello, I am Fabrice Fontaine. I am an embedded security expert working at Orange Labs. In my daily job, I am pen testing IoT devices as well as prototyping innovative solutions such as IoT Safe.
Great. So as some of you may have read in the press, SoftBank has signed a definitive agreement for ARM to be acquired by NVIDIA. That sale is subject to certain conditions, including regulatory approvals. But ahead of this, ARM has decided to spin out its IoT Services Group businesses, which aren't part of the acquisition, into separate wholly owned subsidiaries. Kigen was launched on November 2nd with a mission of securing connected devices and the vision of driving eSIM technologies to be the cornerstone of IoT security. Both of these are in order to bring the long-awaited scalability to the IoT space, especially cellular IoT, and also to ensure that IoT is built upon a strong foundation of trust. Over to Leila to introduce Orange.
Orange is a mobile but also multi-services operator, which is present in many countries and is a quite famous brand in the world. So recently we have decided to accelerate the transformation of our services towards IoT market. So we do already have IoT offers to the mass market customers. So we are selling IoT devices in our shops, Orange shops. And we do have a huge variety of IoT offers to our business customers, proposing SIM cards, which we can use in diverse IoT objects, and a platform, cloud platform, to connect and to collect the data from these objects. And our next targets, as a short-term target, are to scale up the cybersecurity and to install more trust in IoT devices, because what we believe at Orange is that if customers they have trust that the devices are secured, that there is no leakage of their personal data or whatever, the market will grow and it will give us an opportunity to introduce more services and to have more business. Also, we would like at Orange to increase the use of the data we are collecting, because we are collecting a huge variety of data about our customers, their usage, their mobile phones, other devices they're using. So, but all this data can only be used if customers trust on the security, if they are sure that we do not leak any personal data, that on internet no one will discover their position, the camera flow, or whatever. That's why the security of the data is in our main targets for now. And of course, we are investing a lot in the networks. So we are very, very present in 5G developments and fiber, virtualization. We are participating in many standardization bodies to be able to be in the heart of network evolution.
Great. Thank you, Leila. So one of the key barriers for IoT to scale is how to enable pervasive connectivity, especially leveraging low-powered wide area network technologies such as NB-IoT and LTE Cat-M. Let's take a look in this first part about how to secure such devices thanks to the disruption that an integrated SIM approach brings and a first groundbreaking use case. So when SoftBank acquired ARM back in 2016, the focus was clearly put on bringing IoT to scale. If you look at how long it took us to reach 100 billion ARM-enabled chips, which are usually in the mobile space, it took 26 years, imagine. But then if you think that already we're close to the 80 billion mark since 2017, and by 2021 we'll reach the next 100 billion in only 4 years. It's an incredible acceleration around the number of connected devices. The original estimate to achieve 1 trillion connected devices was 2035, yet GSMA intelligence numbers from earlier in the year indicated, at least in the cellular IoT connections, that there would be a 4 to 5% decline over the next 5 years, with a return to pre-COVID forecasts from around 2026. And I'm sure that non-cellular will also be impacted somewhat. So give or take some initial COVID delays, we won't be far off, and 1 trillion devices may even be achieved earlier than 2035, thanks to the digital transformation efforts that are accelerating at all levels, and that trend will likely continue post-COVID. iSIM is the next generation of SIM technology with the potential to revolutionize cellular IoT connectivity forever. Simply put, it moves the SIM from a separate chip into a dedicated silicon area which sits alongside the application processor and/or cellular radio on a purpose-built system on chip. iSIM can reduce the standby power consumption by approximately 70% compared to multi-chip designs, which is a real game changer for devices with a lifetime built-in battery. iSIM is 98% smaller than eSIM, reducing the circuit board footprint and releasing the more valuable silicon real estate. It provides 10 times performance enhancements for use cases requiring crypto, like IoT Safe, which we're about to explore in a few moments, or to protect the subscriber identity in 5G networks. It eases integration and simplifies logistics for ODMs and device makers because it can support either a classical SIM OS, providing a fixed network connection for the lifetime of the device, or an eSIM OS, providing the possibility to change networks over the lifetime of the device. Or, for example, to manufacture a device once with a single SKU and to ship it anywhere in the world and connect to the preferred local network. All of this at a price point which is 50% cheaper than eSIM. Fewer components and a simplified PCB help to reduce manufacturing and logistical costs, which offers significant savings for large-scale IoT deployments. Very importantly, trust and privacy must be the foundation on which to build IoT in order to allay consumer concerns in connecting devices which were previously unconnected. An iSIM offering an eSIM OS provides an industry-recognized level of certification for the storage, management, and handling of the subscription credentials. iSIM truly is a game changer at all levels and will enable cellular connectivity where it hasn't been possible before, like a smart label. Let's take a look at this video to see what we've put together with Vodafone, Sony Semiconductor Israel, and Murata to help Bayer, the life cycle sciences giant, to protect the integrity of their products from the factory to the field. And I mean that quite literally. Exciting, eh? As you've seen, the label comprises of a battery that lasts 2 years, as well as a temperature and humidity sensor and an accelerometer to detect sudden movement, such as the package being dropped. The label is literally paper thin, and you wouldn't know it had cellular connectivity integrated to look at it. We're really thrilled about this use case that was put together with our partners at Sony, Murata, and Vodafone, and we believe it could really be useful for the shipments of products of a certain value or critical in nature. Maybe vaccines, who knows, but let's see. iSIM allows organizations to really realize their digital transformations through the development of new devices with inbuilt cellular connectivity and brand new business models, as well as the various markets that we're addressing on the slide, such as healthcare, agriculture, utilities, logistics, or consumer goods. We're starting to see many new use cases requiring invisible connectivity, leading to insights as a service. In one example, this is where a product manager can at last understand product and service usage to improve and fine-tune their product or service features so that they can manufacture once and ship anywhere. In another example, this could be used to shift from an outright purchase scenario to subscription-based models for some consumer electronic devices. For example, there's nothing stopping a premium brand company offering their consumers products that would typically retail for hundreds of dollars for a low monthly subscription fee. In order for digital transformation to come to fruition, however, we need to ensure that we can securely communicate back to the cloud. So enter IoT Safe. In this section, we'll walk you through what IoT Safe is, and then later we'll see how it's been leveraged by Orange to protect their data from chip to cloud. Leila, would you like to get us started and tell us how this came about?
Yeah, thank you, Paul. Thank you. I really love this handsome guy on your video who is doing nothing thanks to iSIM technology, but only drinking his coffee. I really loved it. So IoT Safe. IoT Safe here, what you should understand is that it's not something which was developed by Kigen ARM company or Orange. It's a result of a broad collaboration of industrial players who everyone understands that we need some security, more end-to-end security on the IoT devices and in general in IoT business, as we need customers to trust to these objects. And it makes 2 years now we are working. The work is led by GSMA together with the TCA, Trusted Connectivity Alliance, to work on the standard, how to leverage some element in a hardware to protect end-to-end security. So we do have in this group mobile network operators, cloud providers like Microsoft, operators like Telefonica, Vodafone, Orange, device makers, modem makers, SIM providers like Idemia, Thales, network infrastructure providers, secure IC vendors. So all together we were working on the specifications to allow this technology to be standard and to be interoperable.
So what's the idea of IoT Safe? The main goal of IoT Safe is not to develop something specific to the telco environment and asking clouds to go and implement something defined by 3GPP or ETSI. Current cellular radio technologies only encrypt traffic from the baseband in the modem to the E node B or G node B, which is usually close to the antenna in a local site or telco edge node. From then on, you depend on an application layer, so the security there, for the rest. In rich devices, this is where you see the HTTPS in a URL, and most browsers will indicate a secure connection with a lock, so you can see that transport layer security is present, formerly known as Secure Socket Layer or SSL. IoT Safe uses TLS, so rather than building something new and cellular specific, we're using existing security protocols. The idea behind IoT Safe is to leverage tamper-resistant hardware, such as the SIM or secure element, to protect the credentials used to establish this TLS layer, using the same grade of security as we use to protect the network credentials themselves. What sense does it make to protect the network authentication credentials in the safest place inside the device, and to load credentials used to authenticate to the enterprise cloud in basic flash storage, or to require an additional secure element to duplicate the functions provided by a SIM? None. So we set out to boost the security at the endpoint by leveraging what already exists in the cellular space, the SIM or the eSIM and now the iSIM. And this means that we don't need an additional external secure element to store these credentials because we can use what we already have. So let's summarize the benefits of IoT Safe. So what problems does it solve and what are its benefits? Well, firstly, recent intelligence shows that most IoT devices are still storing private keys used to establish a TLS connection in the flash of the device. Would we ever consider putting network credentials here? Well, no, of course not. So why would we put the application credentials there? It doesn't make sense. And then to counter the fact that these keys are not being stored securely, we then kind of try and patch the system by refreshing them more often. So clouds, for example, will typically issue certificates, but they'll put an expiration date of 3 months, 6 months, 9 months, 12 months, after which the certificates need to be refreshed. But what if we could extend their lifetimes? We have devices which are constrained, which sometimes need to have a lifetime certificate. And for years in the cellular space, we've spoken about the need for rotating the network authentication keys, but in reality, we've never done it. Why? Because they're stored securely. And why can't it be the same for those cloud credentials?
So the advantage here is to allow us to have a provisioning or on the air provisioning, which does not need any going to manufacturer to putting again something in a hardware. So we are able to provision this through SIM card technology without any manufacturing involvement. And the last summarizing benefits is that it brings IoT Safe, can bring a trust and some value adding to IoT service providers, meaning that they can announce and they can secure exchange with the cloud, and it will help them to bring some trust to the offer which they're providing to the customer.
Okay, thanks, Leila. So let's take a look at how IoT Safe works. So this device embeds an eSIM, but it could be also a SIM or an iSIM. So firstly, the device implements a secure boot, making sure that the integrity of the device remains intact and it hasn't been tampered with. The sensors carry out their main function of sensing, and the device processes their information. And at some point in time, it wishes to share data back to the application cloud. The iSIM carries out the cellular network authentication, and then it opens an IP session. A connection is opened with the service provider cloud, and the IoT Safe application is leveraged to carry out the TLS handshake between the device and the data aggregation and analytics service in the cloud. When the data has been transmitted, the various connections are closed, and then the device goes back to sleep until it needs to sense and communicate data back to the cloud again. Now let's walk through a use case. Leila, over to you.
Yeah, thank you, Paul. So some simple use case when some company wants to offer security cameras. So they will purchase, first of all, embedded SIM from embedded SIM manufacturer, which will go to the security camera manufacturer, who will embed this embedded SIM inside the security camera, and then security camera company will purchase it from a manufacturer. Up to now, there is no keys embedded inside this product, and the security camera company will purchase some subscription from a mobile network operator so that the cameras themselves, they can communicate over the network. And security camera company will sell the offer to the end user and install the cameras in an end user premises. So then the security camera company will be able to tell to the end user, look, I will protect your data. There will be no way anyone can see what is the security cameras are filming and to access to this data. And to do that, they will use a remote SIM provisioning, which will allow to provision embedded SIM, and which will allow to the embedded SIM to retrieve a certificate using the keys which were provisioned on the flow 5. They will retrieve a certificate on the flow number 6, and then they will be able to establish a TLS handshake and mutual TLS connection with the cloud. And the exchange with the cloud of the data will be protected. And so the security camera company, they will be sure that no one will steal this data, and the end user will never get his privacy stolen.
Great, so let's have a dig further into the reference architecture, and over to you, Anurag.
Thanks, Leila. Thanks, Paul. So, okay, let's have a look at the system reference architecture of IoT Safe. And here we have this IoT device, which actually has IoT Safe enabled eSIM. And now this IoT Safe, we know that it's capable of performing mutual DTLS authentication with the IoT server as well as with the edge servers, which can be both like PKI or PSK schemes as well as the symmetric or asymmetric schemes. To do that, IoT Safe definitely requires the credential of the server. So here we have a third party which will provision the credential of the server into the IoT Safe, and this provisioning of the credential can be of two types. One is the push provisioning, another one is the pull provisioning. So in the push provisioning, what this third party will do, it will just push the credential, server's credential into the IoT Safe, which will be maybe the public key of the server or the certificate of the server and client as well. In pull provisioning, the IoT Safe itself will generate the key pair and send back the public key to the third party service. So now here the important thing is that IoT Safe can keep the keys secured in the long term, because we are not storing the keys inside the flash. Next slide, Paul. Thanks, Paul. So now let's have a deeper look into how IoT Safe works into the devices. Here we have a cellular modem, which again has a IoT Safe enabled eSIM. And here you can see we have an IoT application on top of that, which actually is compatible with the IoT Safe. And the very important part is the middleware, which actually responsible for the transparent exchange between IoT app and IoT Safe applet. So actually, once we have the middleware, then the developer of the IoT application doesn't have to care about how to talk to IoT Safe. So the middleware will provide the APIs to talk to IoT Safe, and inside, like maybe in the background, it may be talking to the IoT Safe SIM via AT commands or directly via APDUs. But the developer doesn't care about this. It will just use the API and it's done. Also, this developer also don't have to care about which TLS stack to use or maybe how to use the TLS stack, because these TLS stacks are responsible for doing the TLS handshake with the server, and it can reside inside the middleware or maybe at the OS side, but it doesn't any make sense for the, let's say, the developer doesn't have to care about where the TLS stack is. The middleware will take care of it. Developer just need to use the APIs. And as you can see here, we have some examples of the TLS stacks. For example, OpenSSL, Embed TLS, Wolf SSL, or BRSSL. And we are already working with the few of the open source TLS stacks to incorporate changes needed for the IoT Safe. For example, it's the Embed TLS. Next slide, Paul. So enough of theories. So we'll now move to practicals, and we'll see how IoT Safe work in action together with Fabrice. Next slide, Paul. Yeah, thank you, Paul. Now, as we talked about, the IoT Safe will have credentials stored inside it. So these credentials will actually is stored in the IoT Safe applet as an objects, and those objects will be identified as an ID and optionally by label as well. Creation of these objects are the proprietary. The specification doesn't state how to create those credentials and even how to manage those credentials. So these managing of these objects are proprietary implementation, and the implementer of the IoT Safe applet are free to choose anyone. And now the keys, and we have those objects, and those objects has the keys and certificate, and these keys and certificate are updated remotely as well. And this is also something which is proprietary. The specification doesn't specify how you are going to update those keys and certificate. And now the most important part is that this IoT Safe applet, as you can see, it's using the Java Card Crypto APIs. So this actually makes IoT Safe applet interoperable. So that means if you have a eSIM which actually supports Java Card 3.0.5, then you can install this IoT Safe applet on that. It doesn't matter from which vendor you have the eSIM. And this actually IoT Safe applet can be installed on ISDP or MNOSD, or maybe in the future of the SAM-SD as well. And the SAM-SD is actually the SD, which is where you can have your applet, which doesn't, let's say you have the IoT Safe applet on SAM-SD, and you install another profile, your the IoT Safe applet will remain there because it's on the SAM-SD. It doesn't go away with the profile. Next slide, Paul. Thanks, Paul. So we have two versions of applet, as you can see. Applet version 1 actually supports everything, means the symmetric and asymmetric schemes, while the applet version 2 doesn't support asymmetric schemes. It only supports the symmetric schemes. And In the applet version 1, you see there is an asterisk on the RSA, and because this is the optional one. So they make RSA optional because by 2023 we'll need RSA 3072 to be secure. And the constrained devices, for example this eSIM and iSIM, that doesn't support the RSA 3072. So it's better to move to the better one. So ECC is the mandatory one, and RSA is made optional by the GSMA. So it depends on the use cases or maybe the requirement of the customer. If they want which version they want. Obviously the applet version 2 will be the lighter one because it doesn't support some of the functionalities. Next slide, Paul. Now let's have a look at the lesson learned. We did implemented it. We did work with the Orange, and we did POC of this IoT Safe applet, and we learned some lesson from that. So let's have a look into it. First of all, we learned that the hardware that we need to use, it should be SC300 processor, or maybe the better one than SC300, and because we tried SC000 as well, and the performance of SC300, it's 10x better than the SC000 in terms of cryptography. And then also we realized that if you know your cloud beforehand, then it's better to provision the keys and credentials at the personalization time. The next one is the application ID. It was actually missing by the GSMA specification, but it was later added. And then comes the validation part. So as you know, this the test pack of the IoT Safe, it's still not available. It's still under discussion, and may be available in the Q1 of 2021. So we developed an in-house test suite for it to validate our IoT Safe applet. So what we did in the the test suite, we created a test suite in a way that we doesn't have to use the fixed type of data. When you run the test cases, it always uses a random data, even if you run the same test case twice. So that's how we validated our applet so that it can be used in the field without any problem. So next slide, Paul. So now I'm handing over to Fabrice. Yeah, over to you, Fabrice.
Thanks. So I will now present you the Iot Safe Prototype, which is the result of our collaboration with the ARM Kigen team. So what is LiveObject? LiveObject is a commercial Orange IoT platform, which is used to connect 16 million of IoT devices. One of the goals of LiveObject is to simplify the IoT infrastructure for companies and IT integrators. To do so, LiveObject supports a wide range of cellular connectivities and network protocols from MQTT to CoAP. Moreover, multiple security options can be enabled from legacy connection using a simple API key to a strong and mutual TLS authentication. So thanks, Paul. So to help integrators and manufacturers to produce devices which are pluggable to LiveObject, Orange also provides starter kits. Starter kits are open source implementations of LiveObject's clients for some of the most well-known IoT prototyping platforms. Starter kits can be divided in two sets. Starter kits for very constrained devices, such as Arduino. In this case, the TLS client is embedded in the eSIM, and it can be enabled by the manufacturer, but it is only used to authenticate the server. There is no real client authentication, and the TLS stack is hard and costly to update. On the other side, we have also starter kit for more powerful devices, such as Raspberry Pi. On this starter kit, the manufacturer can easily enable a mutual authentication, but in this case, the certificates and private keys are mainly saved in plain text files. And as a result, an attacker can easily retrieve them by dumping the flash or SD card if he has a physical access to the device. So from our perspective, IoT Safe is an interesting hybrid solution with a TLS client in the rich OS, but with the keys in the eSIM. So our goal in the prototype is to prototype the IoT Safe solution on the most recent and constrained devices, the Arduino MKR NB-1500 with its 32 kilobytes of RAM. So what are our goal for our prototype? Our goal is to prototype the first GSMA scenario with keys preloaded in the applet. So why do we want to do this? We want to do our prototype to check the feasibility and interoperability within the Orange IoT ecosystem. We want to support the GSMA initiative and improve the specification. And lastly, we want to provide a public demonstration with selected partners. So what we have to do technically? So the first point is to enable the mutual authentication with elliptic curve client certificate on the live object starter kit. Because as you have seen, RSA is optional on the IoT applet type 1. So we have to enable the elliptic curve, and the verification of the RSA server certificate will still be done in the rich OS by the TLS stack. The second point is to get an IoT Safe applet. So we have done this thanks to our partnership with ARM Kigen team, which provided an IoT Safe compliant applet, which will realize the storage of the different keys and client certificate, as well as the cryptographic functions related to these keys. So IoT Safe applet can also provide a pseudo-random number generator to the rich OS. And the last point to do is to develop an IoT Safe library, which will be the glue between the TLS library and the new SIM API, which has been standardized by the GSMA. So what are the key facts of our prototype? So at the end of our prototype, we have developed an Orange IoT Safe library, which has been tested with two different IoT Safe applets to verify the AT and APDU interface compliance. We have tested this library with two applets, but also with two TLS stacks, the ARM Mbed TLS and the Arduino BearSSL. And lastly, we have open sourced our IoT Safe library since October 2020. And this library, so it works on the Arduino, but it can also provide an example for on a PC using a PCSC Lite library. So at the end, we have been able to improve also the specification. We have found some small issue in the error code management, and we have found that some additional specification was needed on the signature format. So we have made a change request, which was accepted on July 2020. So I will show in this slide a simple extract of our open source code, which show you how it is simple to use the IoT Safe library to open a communication channel with a private key and a client certificate securely saved in the applet. So the first part of this slide is to show you what you have to do to open and initialize an IoT Safe channel. So you have to just provide a custom application ID or the newly standardized GSMA one. The middle of this slide show you how you can retrieve the client certificate from the IoT Safe applet using the read client certificate functions, and with these functions you have to provide a file ID or a label. And at the end of this slide, I show you how you can easily define the callback to offload the signature operation to the IoT Safe applet using the sign functions, and how you can provide this callback to the Arduino BearSSL using the set ECC sign functions. So at the end, we have been able, thanks to our partnerships, to establish a mutually authenticated connection with live objects, with our Arduino, with the private key and client certificate securely saved in the ARM applet, Kigen applet. thanks. Yes. Oh, sorry. Yeah. Yes. So, what is the next step for us? So, can you go? Yes. Thanks, Paul. So, the next step for Orange and Kigen is to show to see how we could prototype the second IoT safe scenario with an onboard key generation. So in the first scenario, we have been able to check that everything was okay with preloaded keys in the IoT Safe applet, but we want to go beyond and to ask the applet to generate its private key and public key pair using our own over-the-air gateway or a Kigen over-the-air gateway component, and to retrieve the public key to create a certificate and to provision it to our live object platforms. Through this second prototype, we want to be sure that there is no interoperability or proprietary lockdown on the over-the-air interface. And the last point that we want to check is we want to integrate IoT Safe into release version of major TLS stack. So we have already done this for Arduino bare SSL, but we could also integrate IoT Safe, the IoT Safe library, which is licensed under a permissive BSD license. We want to integrate this library into other TLS stacks, such as OpenSSL. So I will now let the floor to Paul and Leila for the conclusion.
Thank you, Fabrice. So yeah, I really appreciate this effort, Fabrice and Leila. Thank you very much. I also just wanted to highlight one point that Leila raised earlier on about the origins of IoT Safe, and that it was truly an industry collaboration between many actors at the GSMA, at the Trusted Connectivity Alliance. And indeed, what we're showcasing here, we're doing it as Kigen and Orange, but in fact, there was a group of people behind bringing IoT Safe this far. So a big thank you to everybody. So just to summarize the key points from what we covered today. So as Kigen, for sure, we believe that iSIM is the catalyst for embarking cellular connectivity into many devices which were previously unconnected. And we believe truly that IoT Safe brings the same level of trust as that of the network credentials, thanks to leveraging the hardware tamper resistance elements of an eSIM or an iSIM. And we truly believe that this is a big game changer in that space.
And what we think that combined this iSIM technology and IoT Safe, they are winning combination, and the Java card technology is a key enabler for interoperability. And IoT Safe, it allows us to remotely provision cloud credentials and to keep them secure, meaning that they are not stored anymore in the flash, where it can be easily dumped, like Fabrice said, as soon as we have a physical access to the device. The keys are kept secure, and we are able to remotely provision them, so there is no need to go again to the manufacturer and to put them in the hardware during the manufacturing. And I think here we are.
Thank you to all the presenters, and I think it's time for a Q&A session. We are about to open the mic, so if you have a question, just unmute your phone for a while and you can ask the question directly. While you are preparing for your question, I have a first question on the chat from Mihai Krianga of GND, who is asking, why is the iSIM 10 times faster and more powerful than an eSIM?
Yeah, so that's a great question, Mihai. So again, this is based on benchmarks that we've done with some of our initial silicon partners. It's to do with the communications between the various components, and it's to do with optimization at that level combined with the processor and having everything within the same system on chip design versus going outside of the system on chip to do things elsewhere. So it's more to do with the communications between the different components combined with everything being in the same place.
Okay.
Any questions? In the meantime, I have one myself, which is about the market with the iSIM and the IoT Safe. Do you think it will be reserved to high-end devices because of, I don't know, the footprint with Java card and everything, or you think it will be able to address also down to low-cost devices?
No, I think that IoT Safe scales to the various different types of devices. And again, one of the reasons that we as a group defined the two different flavors of applets was because one had symmetric based cryptography and another had asymmetric. And of course, the asymmetric type, let's say, it requires some kind of hardware acceleration, but the symmetric type will run on almost anything. And then with regards to the market, yeah, it's up to the market to decide exactly what type suits the device environment best.
Okay, thank you. There's a question from Bassem Ali Abdou. Is there a guide to make for the service developers who want to develop services on top of IoT Safe?
Yes, well, so let me answer that question, and then maybe I'll ask Fabrice also to comment. But from my perspective, the good news is that developers actually have nothing to do when it comes to IoT Safe, because they'll call the same APIs as they would normally call in their favorite TLS stack. And then the fact that the SIM or the eSIM or iSIM is being leveraged to communicate back to the cloud should be something somewhat transparent, provided that they have the, let's say, the service integrated, the IoT service integrated somehow. But at least from a TLS stack perspective and an embedded development perspective, the calls will be identical to that you would normally use in the TLS stack. Maybe Fabrice, you'd like to complement?
Yes, that's it. Mainly the service developer has to provide, as I show you, some kind of ID or label to tell the stack what is the client certificate or private key to use. But as soon as the main TLS stacks, such as OpenSSL or Embed TLS, are made compliant with the IoT Safe using the Orange open source library or another one, I know that another partner inside the GSMA has also open source another IoT Safe library. It is relatively transparent for the service developer. So just a service ID, an ID or a label.
Thank you. I have another question from Carl Weaver that asks if you have any specific use cases from Orange that will require a high level of security in the IoT world.
I think every time we're transferring a data, we need a high level of security. But at Orange, we do have some big customers like gas companies, electricity companies, which are transferring to the platform, to the IoT cloud platform, the information from the counters and sensors installed in a customer's home. So they do require from us the high level of security, because they are what we call in France a vital operator, meaning French government requests from them to be up and running every time whatever happens. I'm talking about gas and electricity companies. So they do request from us a high level of security, and we need to satisfy these requirements, and we need to prove that we, with our business-to-business IoT offer for their sensors, are satisfying these requirements.
Okay, thank you. Another question from Carl is, did Orange deploy already IoT Safe globally?
Up to now, it's a proof of concept. We have connected, so we have used IoT Safe to connect to our live objects IoT platform, which is a real cloud platform we are using for our customers, like I described you, but we have not yet deployed it globally because it's first proof of concept up to now. And as I told, the next step of our proof of concept is to proof of concept OTA provisioning, so that we are able with the OTA platform over the air provision keys also. So we need to achieve this first before deployment.
Yeah. So yeah, and one thing to be clear on, you know, so one of the slides covered from Anurag covered device enablement. So hi Carl, and basically the step of integrating the necessary means by which each of the TLS stacks, each of the major TLS stacks, can access the SIM. Is extremely important, you know, to get right and to get into the various TLS stacks. So there's an enablement piece which needs to be put in place in order for this to scale. Then you'll have many different operators who are able to offer this as part of their service to enterprise customers, and it will be kitted out and will come as standard on devices if you like. But all of that is being put in place together with our colleagues and partners at the GSMA, a Trusted Connectivity Alliance. We're all working together on that before it will scale.
Any other question from the audience? We have one from Kalinel. How does Orange view the attestation of the device hosting the IoT Safe applet?
You mean attestation, meaning certification?
Kalinel, you want to maybe to?
Yeah, I think I understood the question. So in Orange, we do have.
Actually, I mean attestation, not certification. Attestation of the device. How do you know that the device which hosts the IoT Safe applet is the device you want to talk to?
I mean, how you authentify the device when device is connecting to the platform? Fabrice, you understood the question?
Perhaps what could, yes, your question is that if we use a SIM card, it could be removed from the device and used on another one, or is it this question, or because
No,
if this is an eSIM, yes, sorry.
So your device is hosting a system on chip SIM, and your device is composed from different hardware, like the secure element, the host device itself, and probably others. The IoT Safe applet is running as a system on chip, and the system and it's as secure as the system on chip in the hosting device as such is itself. So you must attestate the device as such, otherwise you talk to something and you don't know what you're talking to. So you need to have some device claims, including the device itself, the secure element itself, so that you know the IoT Safe applet is running in the secure environment you want to talk to.
Yes, I don't know. I don't think we have done this in our prototype, but yes, it's a interesting question. But
I think this is something which we can raise in a GSMA group, because it's definitely to be worked with the chipset vendors and secure element providers who are also participating in GSMA and TCA work.
Okay, we have a question from Juan Perez, which is on the applet. How do we ensure that the applet can be installed? Okay, the question is more, the IoT Safe applet can be installed in the ISDP. Will the GSMA specification, the SGP specification, be updated to allow it?
Yeah, so that's a good question, Juan. So again, that's something which could be done. However, I believe that from a GSMA standpoint, the intended target would likely be either to put it under the MNO's SD, or to put it inside the SAM SD, which is under definition, which Anurag mentioned. So this new secure applications for mobile security domain is an ongoing piece of work at GSMA, and it allows an area within an eSIM or an iSIM, or eventually a SIM, I think, to be used for third-party applications. So it's a security domain open to others, which is independent of, let's say, the typical ISDP, ISDR, but it's really sitting externally, and it's independent from the usual, let's say, GSMA remote SIM provisioning area. So it's a separate area that would be used for loading third-party applications. And the advantage of that is that anything loaded in that security domain would be would be managed independently, meaning that you could update the SIM profiles, and you could still keep your credentials for the enterprise cloud completely independent, and you can both can evolve without impacting the other.
Okay, we have a question from Pallavi Madhwar. The way I see it is also related to the start of the discussion on trust and certification. The question is, the keys and certificates are stored in the applet. How does it ensure that it is highly secured as compared to the keys stored during manufacturing?
I don't quite understand the question, because again, this would be stored let's say in a similar fashion. So when I'm not sure what the keys stored during manufacturing versus the keys of the Iot Safe. I don't know what keys Pallavi is specifically referring to regarding the keys stored during manufacturing. But indeed, both sets of keys are going to be stored by the application, and only the application would ever have access to those keys. Then, secondly, well, at least a private key. Or a PSK, which is the pre-shared key. But then one thing which Fabrice touched upon, which I like personally, is the fact of being able to do onboard key generation, and to be able to literally make sure that we generate a key pair on the device. We send back then the public key for certification in a CSR request, and then we download the certificate. So this is for me the most secure and the best case, because this means that the private key is generated on board and it never sees the light of day beyond only the public key is ever sent back. That's part of the normal TLS flows. But I don't quite understand what you're trying to ask with regards to. So it's the same, if you're storing something via manufacturing, if you're storing something over the air, there's a similar grade of security that's in place for the both scenarios.
Is talking about the PSK keys?
PSK keys. So if you're talking about OTA PSK keys or something like this, then again, OTA PSK keys are being stored in secure personalization, and then we are using those keys to be able to download certificates together with some SCP 03 or 02 keys for addressing the security domain specifically.
Okay, question from Bassem Ali Abdou on the availability of the applet in the market from, you mentioned SIM or eSIM vendors.
So yes, the application is available, at least to our knowledge. So the GSMA spec was released last year in November. It's around the 1-year anniversary of the GSMA spec, if I understand correctly, if I remember correctly. And yes, at least 1, 2, 3 vendors that we know have it, and we ourselves have it, of course.
And there's a comment from Carl. Maybe you want to comment directly about the discussion on the attestation. Carl, can you open your mic? Okay, so maybe Carl has a problem with unmuting the microphone. So it was more a comment on the attestation and how to attest that the data is sent from the right source, and it's mentioning that eventually it would be ready to discuss the topic.
So just to make one remark here, Jean-Daniel, Actually, Oracle is trying to do in the webinar in December a demonstration of exactly the issue of the attestation of the device.
Okay.
So it might be interesting for Orange to attend.
Okay.
Yeah, sure. Sure, good point. And it's an Oracle webinar, or how can we find it?
It's the Java Card Forum webinar. It's
Also Java Card Forum webinar. Okay.
Yeah. It's upcoming.
Which is a good pitch to say that if you enjoy the webinar, there's 3 others to come in the next week. So please feel free to register and attend, and I'm sure the content will be very interesting. It's 6 p.m. In France, so thank you for all the presenters for this nice presentation. Thank you for the attendance. And as I said, you will have the presentation tomorrow in the mail. Thanks to all, and I think for that we can stop the webinar.
Thank you.